So hi guys, mayong adlaw. Welcome to NatzMath TV. So in this video, we are back to our math tutorials. In my previous video, I had presented to you about performing addition and subtraction of rational algebraic expressions with similar denominators. So in this video, in preparation for performing addition and subtraction of rational algebraic expressions with different denominators, we will have finding the least common denominators of a rational algebraic expression. So how do we find the least common denominator of a rational algebraic expression? So we will start this lesson after this intro. So finding the LCD of a rational algebraic expression. So how do we find the LCD of a rational algebraic expression? Before we proceed to our example, we have to take note of these rules. Number one, when we find the LCD, we have to factor each denominator completely. Any factors that occur more than once should be expressed as powers. For example, we have a plus b times a plus b. This can be expressed as a plus b quantity squared. So again, number one, we factor out each denominator completely. Number two, we list all different factors other than one that appear in any of the denominators. When the same factors appears in more than one denominator, we write that factor with the highest power that appears. So if, say for example, we have a squared in the first denominator and we have a in the second denominator, what we are going to list down is just the a squared. So we list all the factors with the highest power. Then number three, the LCD or the least common denominator is the product of all the factors listed in number 2. So let's proceed to our example. Example number 1. We are given this rational algebraic expression 2 over 7 plus 3 over a. So in this example, we have the denominator 7 and a. So if we are going to evaluate, 7 has no other factors except 7 times 1. The same also with a. A has no other factors except a times 1. So we have the only factor other than 1 in the first denominator is 7, and the only factor other than 1 in the second denominator is a. So therefore, since we have no other factor except 1 in both denominators, 7 and a, so we consider both denominators 7a as our LCD. So our least common denominator for this example is 7a. Now let's proceed to our second example. Example number 2, we are given 5 over a squared plus 9 over 5a. So as I've said, in this case, we have our first denominator, a squared, and the second denominator, we have 5a. So we have two factors that appears. We have a squared and a. Then, according to the rule, we only have to list down the factor having the highest power. In this case, our highest power for a is 2. So we consider to list down a squared. Now we have 5, which has no other factors except 1, that is 5 times 1. So in this case, we have the factors that appear in all the denominators is 5 and a. We have 5 and a. List all factors with the highest power. So in this case, we have 5 because we have no other factors of 5 except 5 times 1. So we list down the 5 other than 1. So we do not list down the 1 because it is considered as a default factor. So we have 5, and the other factor is a squared because it has the highest power, which is 2. We do not list down the a. So therefore, the LCD for this example is 5a squared. Or the least common denominator between a squared and 5a is of course 5a squared. Now, third example. For the third example, we are given 7 over 8a cubed b and 5 over 18ab squared. So let us proceed first to the variables. We have here a cubed and we have another variable which is a. We have the variables a. In this case, we have a cubed and a. So of course, we have to consider the highest power 3. So we have a cubed. Now we have another variable which is b. And we have b squared. So therefore, we need to consider the highest power which is 2 and that is b squared. Now for 8 and 18, so what we need to do is to list down the prime factorization of 8 and 18. So for 8, we can factor out 8 as 2 times 2 times 2, which in turn can be written as 2 cubed. Okay, so that means 2 times 2 times 2, which is 8, and we can rewrite this one as 2 cubed, which is also equal to 8. Now the same thing happens for 18. 18 can be written as 3 times 3, which is 9, and 9 times 2 is 18. And since we have 3 times 3 here, so we can rewrite this one as 3 squared. Then we copy times 2. So 3 squared is 9 times 2 is 18. Now the other factors that appear are a, in this case we have a and b. So therefore, the highest power of each of these factors are, we have for 8, we have 2 cubed. Since we have here the 8, we have 2 cubed. And for 18, we have 3 squared. So we list down the highest power, 2 cubed and 3 squared. We do not need to write 2 here, this 2 here, because we already have written the 2 here. We only have to write the factors with the highest power. On this case, we have the cube. And the power here is only 1. So we do not have to write the 2 here because we already have written 2. Then for 3, we have 3 squared, so that's why we have 3 squared. Now for the variables, as I've said earlier, we have a cubed and a. We list down the highest power, and that is a cubed, that's why we have a cubed. And the same thing happens for the b, so that's why we have b squared. 2 cubed, if we are going to simplify, 2 cubed is equal to 8, and 3 squared is equal to 9. Then we multiply, 8 times 9 is 72, and we copy the variables a cubed, b squared. So therefore, our LCD, or the least common denominator for these fractions, is 72 a cubed, b squared. Now let's proceed to our third example. We are given this rational algebraic expression a over x plus 5 over x minus 1. Now, if we are going to evaluate each of the denominators in these fractions, we have the x and we have x minus 1. We have to take note that we cannot consider x and x here as the same factors because x minus 1 here is one factor. This is considered as one factor because it is enclosed in a parenthesis. So therefore, if we are going to factor out x, we have no other factor of x except x times 1. And for the second denominator, that is x minus 1, so we have no other factors of x minus 1 except x minus 1 times 1. So therefore, the only factor other than 1 in the first denominator is x. That's why we have here the x. And the only factor other than 1 in the second denominator is x minus 1. So therefore, we consider the LCD, or the least common denominator of these two fractions, is x times x minus 1. Now let us proceed to our last example, example number 5. We are given these fractions: 7 over 3x squared minus 6x minus x squared over x squared minus 4x plus 4. So what we need to do here first is to factor out the denominators one by one. So we factor out the first denominator and factor out the second denominator. That is, factor out completely. So that's why we have 7 in the numerator over, we factor out the common monomial factor in the first denominator. So the common monomial factor is 3x. and the remaining factor is x minus 2. When we multiply 3x times x minus 2, we distribute 3x times x, which is 3x squared. Then 3x times negative 2 is negative 6x. So that's why the factors of this binomial is 3x times x minus 2. Now for the second denominator, x squared minus 4x plus 2, since this is considered as a perfect square trinomial, so we can factor this out, and the factors are x minus 2 times x minus 2. So we have the same factors because this is considered a perfect square trinomial. Now if we are going to evaluate, we have 7 over 3x times x minus 2, and the other one is x squared over x minus 2 quantity squared. Because it is x minus 2 times x minus 2, we consider this one, or we express this one as a power. That's why we have x minus 2 quantity squared. Now we have 3x, x minus 2, and x minus 2. Again, we only consider, we list down the factors having the highest power or degree. In this case, we have x minus 2 quantity squared. So the factors in the denominator are 3, we have here the 3 and this one. Then another is x, we have here the x, and the other factor is x minus 2. We have here x minus 2 and x minus 2. So we list the highest powers of each of these factors. So therefore, we list down 3 and x. Now the highest power of x minus 2 is 2. That's why we have here x minus 2 quantity squared. So that's it. I hope you have learned something from this video.
Please do not forget to subscribe, like, and share to your friends, especially those who are from grade 9 students. So for now, thank you and God bless.